Welcome everyone to the Summer School of Process Mining. It's the first process mining summer school, so you should be really happy that this happens. I think it's a great accomplishment of the research community. There has been a slight change. The first one is apparent. I'm not Will van der Als. I'm Josep Carmona. So Will is like, let's say, like this. So he unfortunately had some health problems this morning, so couldn't attend. So I will make it my best effort to make a convincing presentation. Luckily, this presentation is more like less technical, more on the context of the process mining field. So I hope everyone would enjoy the session today. Let me go with you with a slight introduction to this week. First, giving you some context. This summer school is organized by the task force, IEEE task force on process mining, and of course, it's supported by several organizations, either public or private. And together with Will, we are the scientific directors. It is this year, but our plan was 2 years ago to organize this summer school. And actually, it was delayed because of the COVID. We are happy to say that there has been a lot of impact and a lot of willingness to join the summer school. We have 130 students, and of course, you need to attend all the lectures if you want to get a certificate. And of course, there is social media around that you can use, and a web page where we update any of the news that will arise. Okay. Of course, this is not. Let me check what I can. Yeah. No, this is not. This no. What is the pointer? This one. Okay. So this is the program. It's a very packed program where we will go from very abstract introduction to very detailed. So the sessions during the week will be very detailed. So please be energetic enough to join the sessions and willing to learn all of the topics. So I'm happy to say that we kind of cover most of the topics on the process mining research field. So you will find if you are a PhD student and are trying to drill down in some topic, I'm sure it will be covered in some slot during the week. Okay, so today we will have this introductory session now. Then we will have a session on process discovery. Process discovery, as you will know, it's a very important part of process mining. So there are different slots. There is one today, now, after this session, then one on the declarative part of process discovery, and tomorrow there would be a third slot on advanced process discovery. Of course, you have process discovery, you have conformance checking, which has also 2 slots. Those are the main ingredients, but not the only, but the main ingredients of process mining. But then around the week you will see any other slots like gathering even data, process enhancement, predictive process monitoring, applications of process mining like responsible, robotic, process mining in healthcare. So you will see that we are talking about a research field which is very tied to applications and industry. And that is also apparent in the presentation you will see today. So I want to thank also all the presenters of this process mining. They did not only present during 1 hour and a half these slots, but actually were able to write a research paper, a research chapter in the process mining handbook that we have published just 2 weeks ago. So this summer school is a joint effort of all these researchers, and they will all together were able to write this kind of very important milestone of the process mining research field, which is the process mining handbook. You have this book available. You can get it's open access thanks to the Alexander von Humboldt institution, so you can access that for free. Okay. So, without hesitation, I will move now to starting the introduction of the process mining. Okay. So we're talking here about how the field developed. So first we will start with a certain historical evolution of the field. It's already a field that it's more than 20 years old. So you will see that it has evolved from very niche application to something that is really broad. Okay. So first, positioning what is process mining. As you might know, it's a field that sits in between data science, so where you have many of the typical problems and fields, subfields of data science, and process science, where you can also have any possibility in there, like concurrency theory, operational research, process modeling. Process mining sits in between. And if you look at the two, at the intersections, what pops up at the beginning is process discovery and conformance checking, which takes some parts of any of the intersecting fields, intersecting regions. So process mining, of course, started at Eindhoven University, where there was a research group that was trying to find the marriage between data science and process and getting process models. Therefore, there was early papers on how to discover Petri nets. You will listen, for those of you who are not familiar with Petri nets, you will listen this word quite often, and we will position this formalism as one of the main formalism during this school this week. So there was the alpha algorithm that maybe some of you know. Then they wanted to turn the alpha algorithm something that less discrete, more continuous. Then there was the heuristic mining algorithm. All these algorithms, for those who don't know, they were planned to be algorithms to discover, given even data, traces of behavior. They were aiming to discover process models like Petri nets, or let's say graphs with frequencies that can resemble some process model. And then at that point, that was around 2000, 2005, in this period, there was the need to actually evaluate whether process models that were automatically discovered for the first time were good or not in representing the behavior that was observed in the event data. Therefore, the second field of process mining appeared, which is conformance checking. In there, the goal is different. Okay, you can now invent any algorithm you want to discover process models from event data, but now you should tell whether this model is good or not in representing, whether the algorithm is good or not in finding the right model. So conformance checking then arises. That's a good milestone, but it was a very heuristic. And then there was different, until 2010, there was different proposals to make it more complete. In the meantime, tools started to appear. Like, for instance, there was a PROM framework that appeared in 2004, which contained most of the algorithms. Actually, the research community, and still it's a very vivid community, developing tools and putting these tools available in a single framework like PROM. PROM has evolved, as you can see, towards a huge, let's say, application to use process mining algorithms, and has been a keystone to widespread the research field. But other problems pop up, because it's not only, I put the example of conformance checking, but there were many others. Like, okay, now I have a model, I want to make decisions. So what about trying to use the extra data that I did not use to extract a process model to actually make decisions on the payload that event data has. Therefore, decision mining or organizational mining there has been different proposals so that different problems that in companies, in organizations appear, you can solve them, okay? So, but there was also a new, also a very good, a very important time here in 2009, where some companies started to build commercial tools, and I think there has been this was the first one, I think, or I think it was this one. So there started to be commercial tools that you can use, and it is always a difference between, let's say, academic tools that are not really boost for adoption, but at this point, Fluxicon, Celonis, and many others appear, so that companies started to see, hey, we can do interesting things with these guys, okay? So at this point, Fluxicon, Celonis, all this commercial software started with a very particular way of representing event data. They use directly follow graphs that actually it's a very common sense way of representing event data. On the other hand, as we will see today in different sessions, they have their own limitations. So actually, it's a good compromise so that you can mine process models and, let's say, visualize them easily, but actually, it's not always perfect, the representation you get. But on their way, they gathered a lot of attention, and it was a very special moment, because then industry started and software vendors started to look at process mining from a different perspective. Okay, and also there has been a lot of movement in the last, let's say, 10 to 12 years. I don't want to spend more time on here, but you can see the natural trend going from, okay, we now need education on process mining, so we need to put courses, we need to, let's say, organize schools like this one, we need to organize books, like Will's book that appeared, I think, in 2011, yeah, this one, okay? So, but there has been different books on different, let's say, perspectives, more practical ones. You will see in the last slide of this presentation where there are different books that you can obtain, apart from the great book joining this summer school. Okay, so here you have all these 4 stages that are very important, and this is where we are. We are in 2022. Okay, we have a process mining handbook. We have the first summer school. Where we would be in 10 years, who knows? But I think the trend is clearly going towards a field that will get very mature. And some of the challenges that we have, because there are still a lot of challenges, will be stabilized and solved. Okay? In terms of, this is more or less what I was saying in words. So here, PROM was kind of the reference tool, but then there has been this rise of commercial tools and also this rise of adoption in industry. So let me just summarize from a, let's say, logic perspective, what we do with process mining, okay? So typically you extract from an information system data, and this is something that is not so easy to do. Okay, so there is a special slot in this school for that. Then you can explore and filter. Okay, so this back and forth here between exploring and filter is something that is sometimes unexpectedly hard to do. But once you have the data you want that represents the process, then you can discover. And this is the first problem that we are trying to solve today, how to discover process models from event data. At the end of the day, you have traces that represents a process executions, okay? For instance, order to cash, purchase to pay, or any process you can have in mind, let's say an income in a certain logistic company, and then you have to discover something, you see, that is visual, okay? And if it's visual, it's a process model that represents data that someone can have a look at, okay? So here, I think the emphasis is very interesting, which is, okay, we have data that looks like a table that I cannot really look at the general trend, but then I convert this data into something that looks like a graph that a human can perhaps understand, adapt, and even play with, okay? So it's not something that you do it once, okay? It's something that you can do continuously, okay? I extract data, or I have this model, maybe I forgot something. Let's do this again. So this iterative process on Discover is something that is on the side, or it's done together with a human, okay? Then you can, what I said before, you can also test automatically whether this process model is a good representation with conformance checking and performance diagnostic techniques. That will also give the chance to some human to actually interpret and also drill down, okay? So we can do this manually, but also these techniques give insights, as we will see during the presentation today, give insights on things that we need to correct, okay? If there are misalignments between reality, which is the observed behavior, it's the real data, it's the reality, and the models that we got, then we need to be warned, we need to react, okay? Because the models might be used afterwards to make decisions. Clear? Yes. And finally, you can also do other things like starting from event data here, you can compare, you can use, let's say, out-of-the-box machine learning techniques to actually help to make predictions and make improvements on your event data, your process models. And last but not least, you need to act, okay? So now they're starting to be, so this last part is something that was somehow left for the organization to be done, but now there are starting tools that are also allowing the process mining consultants to actually make a step and take actions so that you close the circle. This is why you got this 360 degrees, because you observe things, you treat the data the way it deserves so that you know what is happening, and then you take actions so that those actions influence the new data you will observe in the future. Okay, so you are kind of reacting and taking actions. This is why it's important, this last. So for the sessions you will have this week, there are some basics that we need to introduce, okay? So I will be gentle, so I will not be very, very formal. You will have formalities consecutively in the slot it will come from now on, okay? But let's start from what type of event data do we care, do we focus? The event data is any event data that is tabular data, so you have, let's say, events are ordered in a table, and importantly, there are three important information, three important columns, if you want, that should be there in the event data. It's case ID, activity name, and timestamp. With these three fields, we can do process mining, okay? So you just need those three. Of course, you can do other things with other data, but because we are first using these events to have a total ordering, we need the timestamp. Because we need to actually display them in process model as elements, as nodes that represents actions, we need the activity names so that they will be apparent in the process model. And of course, and as important as the previous two, we need to know to which process execution each event belongs, because we don't want to mix different process executions if we want to, at the end of the day, get a process model that summarize them all. For this, we need the case ID. Let's go on an example. For instance, the order 6,350, it's a place order, then, it's a place order, then you send an invoice, you pay, you prepare delivery, you make delivery and confirm payment, okay? The order 6,351 is like this, and the order 6,352 is like this. So they are different process executions of the same process, and I want to summarize them into a process model instead of just looking at the numbers and looking at the text here, okay? So the typical idea is that a process, an event log, so contains not just one repetition of the same trace, but many. For instance, this trace here, I think this was trace 1, has more than 8,000 elements, more than 8,000 repetitions, meaning that in the event log, I will have the same trace with different data, because this order maybe was made by me, and this other order was made by my niece, and this order was made by someone that I don't know. And at the end of the day, you have 8,000. Then you have other frequencies, and looking at the frequencies already tells a lot about what to do with this event data, okay? Because it is, of course, important to summarize in a representation, a graphical representation, this event data, but what would you tell if this one, which is the most frequent, is left out, okay? Or what if the opposite? If this one, which is kind of noise, is left out? Would that be okay? It depends on the context. I will not say one thing or the other. But what is important is that frequencies play a very important role in the discovery of process models, because those process models can be affected by the way I get a process model from event data. And in some situations, it could be acceptable to leave out things that are non-frequent. In some others, it's the opposite. Okay, if I'm in a hospital, I want to check whether there are cases that are not treated well, I maybe focus on exceptions. Okay, so frequency is important, play a role in some of the discoveries algorithms we will see, but the magic is this one. I think this is the first slide that I show the magic, and most of you already know, I guess. But the magic is going from, let's say strings of data, if you want, and you get visualizations that actually a human can interpret, okay? So there are different representations that we can use, and of course, the close to the bottom, this is a Petri net, which is a bipartite graph. You have places, you have transitions. There is a token rule you will see in few slides from now. But the idea here is that you can get these process models, and guess what? In the past, people need to model these guys from scratch, from intuitions. Now it's no longer like this. You can get to these process models by simply pushing a button, okay? And that is something that is magic, and it's kind of the way process mining started to expand as a beauty, okay? And of course, in these process models, you can, let's say, you can plot, you can present information. Like, for instance, you can see here in these process models, each dot is a process execution. So you can see where the executions flow through this process model, and you can even give it this information visually. Some of the commercial tools, but also the academic tools, have these visualizations that they look like videos, where you see how process executions enter into the process model and they end up. And then you can see performance and compliance things, okay? For instance, here I can see that in red you have places that are, you get activities that represent that are in some bottleneck, so it takes too much time. Okay, but at the end, you have different visualizations, and any of the commercial or academic tools you will find for process discovery, they do have sliders where you can decide a priori what is the abstract level, how much of behavior I want to see in my process model, how abstract I want to be. I want to see all the behavior or just the most frequent. And those sliders can get you to go from models that are, let's say, what is called the happy path. So what is the most frequent? In our example before, it will be the 8,000 trace and a few more. And then you can open the slider, get more frequencies, and then get more traces, and the model gets complicated. And by the way, this model is a model that we will use, we will see during the sessions this week. It's called directly follow graph. And this is one of the models that I commented before. It's a simplification, but it's very used in commercial tools. Or you can get crazy. Give me all the event data. And if you get crazy, you could get something which is all the traces possible. And why is this happening? This is happening because in reality, let's say normal processes that involve person, involve, let's say, machines, involve many objects around, they actually are full of variance. So you can have, for instance, I have heard that in certain processes in hospitals, there is no single process that is unique. The exception is to have something that is widespread. The typical thing is that everything is a different variant, okay? So if you have this situation, what to do? Is this better than having a table? Depends on what type. If you have automatic techniques that can deal with it and no humans is involved, maybe it's okay. Okay. So here you have some of the reasons why you have this happening. So what is the goal of process mining for organizations? This is you have to. One of the main goals is to simply look at issues, let's say correctness issues, but also performance issues. So you as a process mining researcher sometimes will have someone knocking on your door and tell, okay, I have my company, I have this data, and we are not doing well this thing, but we don't know why, okay? And then you will see, okay, but then what is the type of data you have? This data. Okay, and what is the problem you suspect you have? I think we are very slow in serving this type of item. And then this type of thing kind of triggers the analysis and triggers the reaction. And the type of things you see in process models correspond to the type of problems you want to solve. For instance, here, you can see that if we drill down here this part, you can see that several performance and conformance issues arise. And then you can suggest actions. Because when we have the process model and we have been plotting in the process model certain information, the user or simply the business, the stakeholder, can simply understand where the problems is and ignore the rest, okay? So there is this kind of decompositional view of the problem where you can say, okay, ignore the rest. This is the part where the problem is really, really hard to solve, okay? And this is very easy to be done with process model. So process models are a very good representation of reality, not only because they are nice, it's because they are very useful for people involved in making decisions, okay? Good. So the first part was more on the basics. So we know that process mining is discovery, conformance, performance analysis. There are many other things, but actually you can think on a general perspective, which is these 6 types of analysis that I went through the logic chart that we have before. So here we have this process discovery going from event data to process model, going from process models to look that here you have the process models and the event data, then you have conformance checking, and also you can do performance analysis. Actually, there is a natural order here because for doing performance analysis, most of the time you need to do conformance checking before, because conformance checking is allows to align observed and modeled data. And this is typically necessary for the next step, like performance analysis or predictive process monitoring. But actually, the last step here, action-oriented process mining, can also be influenced by this. Okay? So we have first discovery, conformance, performance, comparative process mining. When you have different ways of doing process mining, you can see and compare them, and there is a methodology for doing this. Also predictive process monitoring, if you want to, let's say, be more operational, and then you have that your decisions not only need to be, okay, we need to hire someone else, but you need to do, okay, now I want to incorporate in my system something that predicts the remaining time and for the users that are in this part of the process. This is something more operational that is also brings a lot of value to the organizations. That is predictive process monitoring, and as I said before, action-oriented process mining. So these are different types. if you tell me this very same question, let's say 10 years ago, all these, let's say, all these 1 to 3 would be my answer, okay? But now you see, there are like 3 more that are as important because they bring value to organizations, okay? And now you ask 10 years from now, maybe things are already considered as solved, and there are steps that are integrated between them. So I can perfectly think that maybe there might be some further problems, perspectives that one needs to take into account. Because I don't know if you see, but we are kind of going out from the data to the organization, let's say, aims. So, and this is very interesting because there are, if I compare to some other fields, it's very hard to get to problems that actually are important in organizations. In here, naturally, the trend in the industry, in the field, is to actually try to move the problems so that they bring value to the organizations. And action-oriented process mining or predictive process monitoring, process mining, are examples of how to go from really very core and, let's say, single and narrow problems to something that brings value, okay? And I hope at the end of this course, you will see this trend very natural. So, the first thing it was done is to keep it simple, okay? So, remember, the tabular data corresponding to an event log has a lot of information, but at the beginning, we ignore most of it. What we want is actually to build a process model, and for this process model, we simply need a case ID, timestamp, and activity name, okay? So this allows us to go simply from event data to process models, and we don't need to incorporate them at the beginning when we mine the process model. We can incorporate them later, and you will see why and how during the sessions today. So first, how to get process models? What are process models more formally? So I ask you a bit of attention in here because I will go a bit formal, very not so much formal, but at least so that you can understand the rest of the slots this week, okay? So let's start with a running example. So cooking a pizza. This is let's build a process model for that, okay? As you will know, Will van der Als loves Italian food, and this is something that is clearly apparent in the slides. Okay, so how would a BPMN model? BPMN model is a model that is used very often in industry, and it's I would say is self-contained, the information of this model. So you so you start. There is a notion of a start event, something that is not happening inside the process model, but it's something that it's external to the process model. Then you start, you buy ingredients, create the base, then you need to decide what to add. Of course, I would say these two for me as a Spaniard are, these two for me as a Spaniard are important. Salami, we have our own salami, so I will not add salami, but something local. But this is something that you can decide in any order, okay? Then you can bake, then eat, and then clean the kitchen, okay? So this is the process model. How many executions does this process model has? Notice that there are the notion of you have actions, and then you have, let's say, operators. In here, these operators are, this one is AND split gateway that simply the ones that are inside this split and join can be done in any way. They can be done in any order. So you can add cheese first, or add tomato first, or add salami first, and then the following action could be any one of the one that was not executed before. This is parallelism modeled in a BPMN model. Okay, but you can also have Petri nets. Petri nets are, let's say, more low-level representation of a BPMN. Actually, the BPMN that I showed before has as a semantics, so the way to explain the semantics of BPMN is with a Petri net, okay? And you can have the same thing. You can see those models are almost isomorphic, so you have You can see that they are not so different. Of course, there are not special gateways because, as I said before, a PetriNet is a bipartite graph. You have you have places where can hold or not a token. Then you have activities that are called transitions. And there is a very simple firing rule that says, in my PetriNet, a transition can fire, moving a token from the places that are in the preset. So, for instance, here the preset is this, the postset is hit. Here the preset is this, the postset is this. So when a transition is enabled, it can fire, putting a token in the postset and removing a token from the preset. Okay, and here the only transition that is enabled is this one. We will see some examples, for instance, now. Okay, so this model actually. And that is something that I didn't say, and it's very important. The models are representations of the reality. So actually, they have the possibility to simply execute traces, so generate traces. They are like language acceptors. So you can, for instance, with this model, generate a particular trace. Whenever you have to take decisions, you take decisions. Whenever you simply need to fire, you fire. For instance, here, as I said, the token rule tells me the firing rule tells me that this is the only one transition that is enabled, so I fire. Remember, I remove token from the preset, I put token in the postset. So when I fire, I'm actually constructing a trace. You see? I'm doing the other way around. So I'm just simply playing in the PetriNet and generating a trace. Okay? So now I can fire CB. And I remember, how was it? This is kind of magic? No. I simply remove one token, and you know, I put one token in every output place. And then this is like this. I have fire in reality, CB, and so on. And now I have 3 transitions that are enabled. I can fire them in any order. So I can, for instance, fire first AT, then AS, then AC, then BO, EP, and CK. Okay? And this is the trace. But of course, this is not the only trace, because all of you already noticed that when I was in this state, instead of firing first AT, I could fire first AC. So actually, the number of traces represented by this model is 6 traces. I can fire 6 different traces because of the concurrency. Okay? In the book, you will see that we will most of the time use a particular class of PetriNets, which are accepting PetriNets. They have a clear initial marking, so a clear initial state, a clear final state, okay? And here you have the formalization. You have P is the set of places, the set of circles, T is the set of transitions, and then F is the flow relation, is the arcs between places and transitions. Of course, the flows relation can only go, because it's a bipartite graph, can only go from places to transitions or from transitions to places, so that the PetriNet is well formed, is correct. And finally, you have this labeling that is telling you, okay, yes, this is a box, but actually it represents a transition, an event in reality. It represents an action that I'm mimicking, okay? So these boxes, if you look at old books of PetriNets, they were simply without names. Now it's very popular to put them names so that you can refer to actions in the data you are referring to, okay? So as I said before, you have 6 possible traces because we have factorial 3 here in terms of executions. Is PetriNets the only way to represent event data? PetriNets or BPMN? No, I already said DFGs, but also there are more well-structured process models like process trees. Process trees are, let's say, trees where you can have 2 types of nodes. You can have nodes that are activities, and then those will be leaves of the tree, or you can have nodes that are operators, and those are very similar to the operators you find here, okay? They kind of give the semantics of the subtree that is pending, okay? In this case, again, for instance, this process tree is the exact representation of the PetriNet before. It's the same, because the parallel operator is telling me, okay, when you are executing this, you can execute any order of the 3 activities that are pending, the leaves pending from this, okay? So you should see no difference between this process tree and the Petri net. They are the same representation, okay? Actually, you can even summarize the process tree as it's a sequence between these two. For instance, the semantics of a sequence is first this, then this, then this, then this, then this, then this. But when I'm executing this, you see, I can take any order that I want among the three activities, okay? So they are different representations of the same process, of the same process model, okay? Actually, you see here the correspondence between this and this, okay? And last but not least, you have directly follow graph. Those are the ones that I've showed before when I was telling the complexity depends on playing with the slider, okay? So here, you can have the same representation. Actually, this is what you will get if you try to play out the 6 traces, and then you mine these traces with the current commercial or academic software, you will get something very similar to this process tree, where you have a start node, an end node, but importantly, you have an edge between two actions if in some trace you have the action that is directly followed by the other, okay? So you can build very simple, very easily, directly follow graph by simply linearly scanning the event log. So from a bunch of traces, 1,000, 1,000,000, 1,000,000,000, whatever, to get to this process model, you simply need to scan it once, okay? So it's very easy, it's very fast, and it's very convincing because you get all the information. Of course, you will see, and we will speak a bit about this, you will see that there is a bit of complexity here that I've not seen before in the other process models. So there is pros and cons of getting this type of process models. I think we'll put I will go afterwards. But actually, the DFG has replaced semantics. Okay, what I did before with Petri nets, I can do it with this. So I can replay. And in here, it's important that there is also the notion of token, which is the last execute activity. Okay, so for instance, here I can fire BI, then CB, and maybe some of you already see that this is very similar to Petri nets. It's not the same. It's not the same, but I would accept that in this inaugural session, you don't notice the difference. What I will not accept is that at the end of the week, you don't see the difference, okay? But it's a slight change, okay? How there is only, the first I will tell you, there is just one token. There are no 3 like in Petri nets because these models lack concurrency, okay? So now I play CB, and now I play, you see, I can only play AT, which moves the token here, and now I can play AS, and then now I can play AC, and then BO and EP, CK. So I can also replay traces with this process model. This is why they are also very valuable piece of information. But actually, for some of you, might realize that this process model is a bit too much, okay? Why is a bit too much? Because to mimic concurrency, I have to introduce this kind of, let's say, cycles here between activities so that I can play one order or the other. And because there is only one token, I need to account for all the possible paths to mimic all the different ways of executing this concurrency. That makes it also the model to accept many traces, so infinitely many traces. So while in the Petri net I could only execute 6 traces, in this model I can be playing here with the token forever, okay? Of course, this is, let's say, acceptable if you are a human and I say, okay, yeah, I know I can play this forever, but at the end of the day, this is just finite, so I can accept this. So these type of process models typically are acceptable because at the end of the day, the use a human gives to them is always finite, okay? But actually, we can add a bit more complexity to the process. The process was very simple, okay? But what if we go to a real Italian restaurant, there might be more choices. For instance, there can be that you you can put a decision between adding salami or adding mushrooms, okay? So this would complicate a bit the BPMN model, having, let's say, an XOR inside the split AND gateway. Or you can decide that you can add as many cheese as you want. Notice that at this point, with this addition here, we are accepting infinite traces as well, okay? But we can accept, even though we might accept that in a practical setting, there would be always finite. But the model per se accepts infinite traces on adding cheese, if you really like the cheese. Then you can accept also that pizza can be skipped. So if you do a pizza that nobody can eat, you can simply skip eating this pizza, okay? So this is a different model, and of course, it's easy to model this in BPMN, but actually this has, as it was said before, it has too many traces. While if we want to do the same with Petri nets, we will not have any problem. We can simply put the choices here. Now the choices, for some of you maybe already grasp, the choices as implemented with a place with two outgoing arcs. So I have to make a decision whether the token goes here or goes here. Or for adding cheese, maybe you didn't notice. I didn't tell that, I think. Yeah, so all this is stands for the names of the actions, okay? So by ingredients is BI and so on and so forth, okay? So for the Petri net, you get a very simple, very similar behavior. For the process tree also, okay? So you can see that the process tree is simply easy representing. Now you have a new node here. This is a redo loop, meaning that I can execute this, or simply when I go back, I go back and execute this action here. But it's the same. This is an XOR, and this is an XOR. And this is XOR is eating pizza or skipping it, okay? So I can perfectly represent this behavior with the process models. Here you have how I represented this in a Petri net, the correspondence. But again, the directly follow graph gets cluttered a lot, okay? So you can see that in order to represent all the behavior together with the concurrency, it's kind of messing up everything. This, please, disclaimer, this is not just telling, okay, avoid using DFGs. This is because we are representing a very particular behavior which is not natural to be represented in DFGs. But of course, the DFGs, I want to stress this out again, they are a very valuable way of representing process models, but this is more on defending us to use Petri nets and BPMN models, okay? They are less used in commercial tools, but actually they can play an important role, as you have seen in this very niche example, okay? Actually, what would be the relation between this model and this model here? Can anyone tell me? What would be the relation? If you consider them as accepting automatas, or if you consider as languages, let's say, so set of traces, who would be, are they equal? What do you think? No. If they are not equal, one might include the other, or one can include the other, or they are simply different. Do you think is there some of the two that includes the other? Yeah, indeed. The DFG is including the Petri net, okay? Okay, so is it this? Okay. So the DFG is including the Petri net, okay? Because the DFG allows to not add cheese, allows to not add in tomato, allows to add both salami and mushrooms. I don't know, is there any Italian in the room? What do you think? Could be. Allows to add in tomato, salami, mushroom multiple times. I think the Italian will abandon the room if we have that. So as you see, actually, a business user can accept both models, but actually it can be, depending on the type of usage you want to give to the model, maybe it's good to go on the DFG, maybe it's good to go on the PetriNet, okay? So they give different abstraction, they give different, let's say, accuracy measures, so one needs to know the type of model that it is using and the purpose of this model, okay? So as a summary, okay? So remember, process mining is all about dealing with process models. They are very important. And is there one choice? No, there are many choices. And the choices are multiplied by the algorithms. So there is not just one algorithm to get PetriNets. There are many. There are many. There is not just one algorithm to get DFG. There are two. There is not just one algorithm to get process tree. You will see that today Sander will show you an algorithm to extract process trees, but then there are other algorithms to extract process trees. So you can decide the algorithm, you can decide the model. Actually, if you decide the algorithm, you are deciding the model. But the other is not the same. So if you decide a model, then you have to decide which algorithm, okay? But the summary, this slide is important for you to remember, okay? So BPMN are good for if you want to talk to business people, okay? PetriNets are good if you want to talk, if you want to really drill down the semantics of these BPMNs that we are getting. So typically the algorithms doesn't, the discovery algorithm doesn't go straight away to BPMN, no. They go to intermediate representations. They can be DFGs, they can be process trees, but they are never at the first level BPMN because they are like high level. And when you have an algorithm, you want something that is precise and drilled down to specifics. DFGs are supported by all process mining tools. So they are very popular, but maybe the goal of this course is to show you that there is life outside DFGs, and especially you can use them to improve the analysis you do afterwards, okay? Any questions so far? Sorry, because I didn't ask about questions. Yes, please, go ahead. You mean here? A proper subject of DFG? Yeah, actually. It was more like a... Any other question? Yeah. Yeah, and I have to apologize because I think my tone was very pessimistic to DFGs, but it's not like this. Okay, so she was asking, okay, if DFGs might underrepresent the reality, why to use them? Actually, what happens is that if you use practical data, there are many problems to get a right BPMN PetriNet model, okay? Because, for instance, the algorithms are not, that derive PetriNets are not dealing well with frequencies, noise, and those things. But up front, the problem is the goodness of DFGs is that they summarize amazingly nice the general trend, okay? So you don't want to go to, actually, what you will see in the reality is that the PetriNet mined from data will look cluttered like this, and the DFG will look like this. Because the DFG, playing with the sliders, you get, let's say, the general trend, like the happy path and the most common things. And they are not, and for someone that doesn't understand process modeling, you can understand, because it's so simple. The arcs between two events are simply one is go after the other. Everyone can understand that. While the semantics of PetriNets, the semantics of BPMNs are not so easy to understand. There are operators in the case of BPMN. So I think the reason by the widespread of DFGs is that they are typically work very well in practice, and they are easy to understand. And this is something that is unbeatable. Some of them. Some of them. Some of them. Yeah. So for instance, Thelonis is one of the tools that from the early beginning was, as other tools were doing, you, focus all the analysis on DFGs, but then if you want to do a conformance checking, they move it to a BPMN model. So for doing particular tasks, process mining tasks, you go to some more like formal models. Nice, thank you. Event data, okay? So sorry, go ahead. Yeah, sorry, because I skipped. So thanks for remembering. So what does it mean, process trees to be sound? Sound. This adjective here, it means that whenever you extract a process tree from event data, or simply a process tree has replay and will never get blocked. You can define a language from the process tree, and there will be no, let's say, execution problems when you replay it, okay? Sounds means that it's correct by construction. And this is a very nice feature that neither Petri nets, BPMNs, they have. Process trees can always execute the traces, okay? This is very nice, okay? Thanks for. And sorry because I'm just improvising a bit, so I'm skipping things. Event data, I oversimplified a lot the notion of event data. Case ID, activity name, and timestamp. I did an oversimplification. Let's drill down a bit for some time. What does means normal event log and simplified event log. Event log has many information, and I'm sorry to say that there is, in the chapter 1 of this book, there is a definition of an event log. Does it work? It doesn't work. There is a definition too of event log that simply tells you what do you need to know. Actually, what you have here is that events are the is here. You can ask for the time of the event. You can ask for any of the payloads you find in the row of the event, okay? But actually, you can deal with a simplified event log, which is the type of event log we have been dealing so far. But actually there is a standard of event logs, which was approved in 2016 by the IEEE, so that you can represent and store event logs in this standard. And that is very important. That was a huge success of the community, so that you can have your data, which is in your database, and then you can simply ask some IT staff to store this data into the standard, which is the XML type of standard where you can have, let's say, all this information that you need for the event log. And this is keep on growing. I will not go into the details of this, but this is very important because event data can be stored, can be shared by using this standard, okay? But actually, now there is modifications of this standard so that you can also represent what is called object-oriented event data. This is a generalization of what I said before, because actually event logs are not only rows, but some of these rows are connected. Imagine that there is an item you are buying, and this item belongs to a particular, let's say, truck that is joined together with the two items you are sending by Amazon, okay? This type of relations, which means there are objects that relate different events that might correspond to the same execution or to different executions, are objects that you can use to analyze the behavior that is in an event log, okay? So this is the new thing in process mining, dealing with, let's say, how to relate process executions so that you can also actually make analysis at a higher level, okay? remember the trend that I said at the beginning. We want to move out from very particular and niche applications to things that are valuable for the company. For instance, if Amazon wants to make analysis on the type of executions that are involved in a certain track, then you can do this type of object-oriented analysis. But this is yet, maybe some of you would finish a PhD thesis on this because it's a very hot topic and it's really on the early stages, okay? So for instance, a place order, so you have deliver package, one package, two orders, 4 items. So I'm not really saying anything deep. What I mean is that some of the cells on this tabular data might be interrelated. So some of the columns might serve as interrelator between different rows. And this is what is the objects that relate them, okay? And there are some papers that you can have a look by Will van der Aalst and Alessandro Berti on how to discover this type of models. So of course, if you want to put this type of information in a process model, you have to extend. So there is the notion of object-oriented Petri nets, and this paper explains how to discover this type of elements. So as I said, remember, 4 types of models, now 4 types of event logs, okay? Remember, and if you remember that logical structure, you can go from different event logs to different process models by process discovery, okay? Simple event logs is the event logs we will be most of the time dealing in the presentation today, in the presentation by Sander in half an hour from now. But then you have normal event logs, the ones that have all the information, object-centric, and then the ones that I can store and interchange in an organization, okay? Questions so far? That was a, sorry, now you hear me. And what about the last half an hour? Well, it was okay. So how many software, it's fine. So how many software do you can find? There is plenty, okay? So you can see here that, but you see it's keep on falling. Okay, so you can find this is the list of software you can find. It's funny that TUI is listed as a vendor for someone that is academic, but anyway, so you can find all the software here. Some of them is academic software, some of them are simply commercial software that you can find. Actually, the general advice would be you start from software that is academic, because it's free, you can get that. Also, there are academic license for most of the software you can find. So if you are in an institution that it's a university, it's very likely that you will get academic license for the software, even for the most expensive one, okay? So I think now we are in a very good situation, because I think it's very nice that most of the software you can have in the market has an academic alliance with the universities, okay? So if you, after this week, like process mining, are totally convinced and are not starting to use some of the software, is incredible, okay? So you should do it. Here you have some of the tools you can get academic license, for instance, Discord, Celonis, or any of the tools you can have this. Will selected 2 types of software. The first one is Prom, the other is Celonis. So we will give a tour over this software in this session today. How much time do I have? That's good. So a bit of a story of Prom. Prom started in 2004, as I said. The release 6.11 has 1,500 plugins. Do you know what does it mean? So there are 1,500 algorithms implemented in the platform, okay? So this is huge, Okay? Of course, some of the algorithms is simply going from an event log to a CSV. But some of them are discovery techniques that are actually, for instance, the work by Sander, where he has this inductive miner that can replay in real time. So there are many algorithms that are absolutely non-trivial and bring a lot of value. It was created to reinventing the wheel. And this means that in research community, sometimes you create an algorithm implementing C, and then some other in Canada does the same, and there is no way to compare. So PROM is also a very nice venue to have the same algorithm so that you can have a fair comparison there. And there was, let's say, sons of this PROM, which is PROM Lite, Nightly Builds, and Rapid PROM, and there might be some others. And it's a GPL license, so you can use it without problems. So what does PROM has? First, you can simply load an event log in the chess format, but also in other formats. So you can load in many formats, even if it's a simple, let's say, text file. I think there are some algorithms to turn it into a chess or something that can be understandable. So first, when you load an event log, you don't have this tabular ugly view, but instead you have something that looks like, okay, the first trace, you can even, I think this is ordered, it's ordered by frequency. It first shows the most frequent traces. In colors, you see the type of events, the type of actions that have happened, and then you have all of them, and you can scroll down to see all the event log. And this is just one view, okay? Here you have a lot of information that you can use, okay? Also, there is the dotted chart view that I hope in some of the sessions you will see, which is, let's say, a more abstract view, not focused on trace level, but more focused on event level. And you can see, for instance, timeline, like in a calendar, where you see, let's say, cluttered information on events, meaning that at that point there was a lot of events happening. And it's an alternative view of what you have seen so far. It's very useful to. One of the first things you would do with an event log is look at the dotted chart to see more or less if there are trends on the time or on other perspectives, because this is kind of highly configurable. Of course, you can discover and plot Petri nets. You can also, you see here there is the play, you can play the Petri net you discover to see what I showed before. So you start from event data, you discover a process model, and now you replay the process model on top of event data live, meaning that you are seeing how process executions flow through your process model. You can also have that in PROM. And you see here that the sliders are already there, even in this kind of DFG level. You can also have the same for Petri nets. You can also do the bottleneck analysis, where you have red, let's say, the reddish is the more bottleneck you have, the higher is the bottleneck. You can also do conformance checking. For instance, you can see that there are some red arcs here with some meaning. There is some misalignment between the reality and what you have been discovered in the process model. This is very interesting because actually it's an abstract visualization of a conformance problem. And remember, what is conformance? I have event data, I have a process model. I want to see whether they are aligning well or not. They represent the same way the reality. And if there are misalignments, you want to be known. For instance, here there is a self loop that is not seen either in the model or in the reality, and here you have some arcs. I don't remember the meaning because this is a new visualization of this, but I think it's are misalignments. Also, you can see misalignments more fine-grained, as we see. Now what you have seen here is I have all the traces, and I look at the traces, having it with the eyes of the process models, and I see when there are misalignments on the traces. For instance, a red in some event here means that this event was not possible to be replayed at that moment, or the opposite. It means that you need to fire something in between before this event. So these colors here show you very easily the misalignments you might have. So the information here, if you look a bit from the outside, you see, okay, there is no trace that is aligned with the process model. Okay? So this is the information you get. And with this information, you can start reasoning. Okay? So this is important information that gives you with conformant checking. And also, of course, PROM also gives you DFGs, discovery, visualization, replay, and so on and so forth. Okay? Also, if you want to use the heuristic miner, which is a miner that can discover with frequencies and so on, you can have something that we are not covering in this session today, which is CNETs. It's another type of model that is, let's say, less broad, but it's also interesting. So as we said, if you go to this web page, you can get PROM, you can get any of the PROM tools, you can get datasets, you can get tutorials. So for those of you who wants to start drilling down, I think it's a very good way to start, because this is a work from a group that is really inventing all this field, but also has a lot of sensibility to, you know, the tutorial part of the problem. So that was a, yeah. PROM Lite. It's the simplest with the minimal set of plugins you need to work. And then if you want to go wild, there are many, but PROM Lite is the one. Now, we had an example of an academic tool. Now let's move on. Yeah, please. Absolutely. Yeah. Yeah, but that was exaggerating. Let's say if you follow the tutorials that come with the tool, you will be guided to use the and from the session today and also from Sanders and some other sessions, you will see that to understand and to apply process mining, you can, let's say, 5 to 6 plugins. You can start playing a lot and doing a lot of stuff. Because some of the plugins already are deep. So for instance, if you play with conformant checking, you actually need to configure a few things. So you would be guided. So my recommendation would be you start with the tutorials. And I'm using PROM, but there are other academic tools that they have similar level of support, like Apromore are some of the tools, and you can do the same. Follow the tutorials and you will start by this. Oh, any other question? So, example of academic tool, PROM, it's not the only one. There are others at similar levels. Then you have a commercial tool, Celonis. Okay, this is as it was founded 11 years ago. As Will posed, it's the most successful commercial process mining tool. That's by numbers. It's true, and it was first devoted and aimed for non-data scientists. And that was a very interesting twist, because at the end of the day, if you look at the tools that were there before 2011, we're more considering, let's say, that the consultor that was using these tools knew a lot about, you know, process mining, process discovery. But this one, it's 11 years old, was more like say, look what you can do, even if you don't know anything about process mining, okay? And it's not entirely true, but it's on this way, okay? Especially, it is highly scalable, and there are different additions that you can find. And in the last couple of years, they have incorporated that last step that I mentioned, which is called action-oriented process mining. And this is simply what I said. Now I can, and we will see, by the way, but this is something that you can do. Okay, you do mining, you do process, you get a model, and then you can execute this model if you connect the right actions to the right applications. And this is through their integration with Integromat that now is Make. Okay, we will see at least a glimpse of this in few slides from now, okay? So, of course, it's a commercial tool. The visualization is better, but please don't retain only this, okay? You can have many of the algorithms that you can find in Celonis. Those are algorithms that come from academia, like the discovery of process models, these type of things. They all come from academia, okay? So, not all, sorry, most of them. For instance, when you enter into the tool, you get this dashboard, okay? And then you can load even data, and you get directly follow graphs, okay? Which looks like this. You can the slider here. You can decide many things, like for instance, focus on, now it is focusing on frequency, but you can also focus on time. You see here the arcs. You can, for instance, between this and this is 52 hours. Maybe, I think it was you who was asking, you see the value now because you can see that instead of looking at, let's say, a table of 1,000, a million of rows, you have this, and you don't have to understand anything. You just need to go here and say, okay, it's normal that the first thing it does is initial examination. Imagine that this is not like this. Then you will say, oh, why is this? Why not initial examination? So looking at this model, you can grasp most of the things you need to know. And this is more or less the trend. So you can have DFG with times. You can have an animation, of course. You can see how this evolves with the dots. The principle is the same. You can have variance. You can have also, you can actually decide visualizations. So this dashboard can be converted into a dashboard that you can design so that you can, let's say, plug in the things you want to visualize for an analysis. And this is kind of a second order thing that was also very interesting. You can, they have this PQL language, process query language, where you can do things similar to SQL, but now querying the process. So for instance, this is the query you will get to compute the remaining time for activities, okay? So, of course, if you know a bit of databases, if you know a bit of this language, you can do things. And actually, they incorporate the inductive mining algorithm to discover BPMN process models. This algorithm you will see in 30 minutes from now, but it's very nice that it's incorporated. So you can not only mine DFGs, but you can also mine BPMN models, and will be shown like this here. Okay, it's not working. And of course, when you have BPMN models, these are models that are, let's say, sound semantics, so to say, so you can do conformance checking. And conformance checking will give you, it's not shown here, but will give you a list of violations. Do you remember how was it in PROM? In PROM, there were two alternatives to show conformance diagnostic. One was, I show the process model and some arcs are in red, or I show the traces and some events are in red. In here, they have this visualization that is a summary first. For instance, here is telling you that all the cases are conforming, there are no conforming cases, and if there were violations, you will see the list, and not only that, some of the violations, you can analyze the root cause of analysis. For instance, the root cause of this violation. They can try to use the data that is in the event log to explain, hey, and this happens because typically we believe that it happens because the applicant was less than 20 years, for instance, something like this. So you can use this type of tools to also drill down explanations on misalignments between event data and process models. Okay? There is one thing that I didn't say, which is important. Process mining is not sitting alone in the landscape of an organization. Before process mining, there were people that were modeling processes. Okay? So, and there still are many people that model process by hand. So there are even tools and commercial tools that allow people to model process, okay? Is this meaning that you cannot, you have to see that as an opportunity. For instance, imagine that you have event log and a model that was modeled by the best expert in your organization. Then you can see whether the event data and the model are compatible. So for process mining is not just working on its own without interaction to other, let's say disciplines, but instead is trying to live together. And conformance checking is a very nice example because models can come from discovery or models can come from someone that models them because it's the one who has the best expertise in your company. Okay? And now, if you have a model that was designed manually, it's great to be able to align this vision from this person to the event data that is the reality, so that you can say whether they are compatible or not. Okay? So in Celonis, you can actually upload a process model that was manually designed and do conformance checking. And then you will get insights of what is the reality and what is the model telling about the reality. And of course, you can get this type of visualizations and so on and so forth. Okay, for instance, here you have a visualization where only 50% of the cases are conforming, and here you have the violation, and here you have you can see a bit the explanation of this visualization, and here you have all the explanations. Okay. This is what I said before with the list. So action-oriented process mining is also possible in Celonis, meaning that you can, once you mine the model, you can actually turn this model into something that can become executable. And what do I mean by executable? Imagine that you can align elements or tasks to executions or integrations with third-party software, like for instance Salesforce or SAP or whatever, okay? So you can actually, let's say, turn the model into something that can be executable, and now it's kind of generating data and generating, let's say, actions by itself, okay? So it's not only modeling, but actually building the house and actually letting the house to go on its own, okay? And this is execution, and Celonis has this kind of nice addition on action-oriented process mining. Could be, because at the end of the day, you are kind of executing instead of humans or instead of organizations. But in here, the difference is that, it's a very good question. The difference is that you are the one who are kind of telling the tool what things need to be automated. In RPA, typically, there is someone that records what you do and then tries to mimic. In here, it's a different way to get to the same execution. Actually, some RPA companies are using process mining to get insights. And in the last, I think it's on Thursday or on Friday, there is a slot on robotic process mining. I strongly advise to go there because I think it's a very interesting also trend. Okay, so there are academic alliance, and I only need 5 minutes to go, so let me go fast for applications. There are a plethora of applications, not only from Celonis guys, but I can see that people from Fluxicon since, let's say, 13 years ago, and many other companies are having use cases that are very important and very meaningful to widespread the application of process mining. I will not go through all the details, but you can see big names here, actually big names. And if you go to the next slide, only for Celonis, you can see huge names here, people applying process mining on use case on the daily basis, okay? So the bigger picture that I want to bring in here is that, as I said before with process modeling, I don't know if it's here, no, it's not here, no, it's not here, but the aim of the community, the aim of the field is to join forces with other fields that are around. For instance, what about simulation is important because simulation plays an important role for organizations. Automation, RPA, you already said that. So the aim is to be in this middleman between event data and all the rest of things you can do, okay? So the advice, the vision of the community is to, let's say, bring tools, bring algorithms, bring technology so that they can feed the, let's say, more the applications that are waiting for this to be applied, okay? But not like they do. They start even from event data. Why instead, if these applications, these fields start from data that is already, let's say, analyzed with a particular purpose, okay? And the purpose here is process models, processes in organizations, the way processes are executed. I think this is a nice turn that adds value to not only process mining by itself, but those applications that are waiting afterwards. So the idea is simply to get insights and turn it into actions. And here we are trying to, especially the companies that are starting to incorporate, let's say, action-oriented process mining, they start to react and close the loop, okay? So that it's not, let's say, individual projects trying to improve, for instance, the process of hiring, the process of logistic, the process of, I don't know, taking a day off, towards something that is a kind of a solid base and connected base for all the processes that are in the company, so that you can scale this up. So summarizing, this is process mining vision, where you have 6, let's say, types of tasks, types of subfields. But importantly, from this presentation today, you have 4 types of process models, 4 types of event data, and what you will see next is kind of how to evolve from event data to process model. This is the session that you will see in a few minutes from now with Sander. These are the websites. I think the slides are available for the audience. So you can access all these, and this is just a subset. Especially, there is this website here, Task Force of Process Mining. Here it's a very nice hub. You have newsletter, you have many information that is pointing towards some other structures that you can access, books, resources, and interviews with important people. I think it's a very nice. But all the rest is also interesting. And also there are online courses that complement the summer school that we have here. For instance, there is this process mining and data science. There is this process mining that is joined with Celonis and the university here in Aachen. And of course, there are books, okay? And this is kind of, we are very happy that this book is already maybe in your pocket. But the most important book so far is Process Mining by Will. It's the 2nd edition already. I don't know if there would be a 3rd edition, maybe. But it was kind of very popular book, and you should have a look also this one. Other books that, actually this is the 1st edition, the 2nd edition. Then is this book on process mining in action by Lars Lankemeyer as an editor, where you can see use cases in industry. It's very interesting from another perspective. Also this is nice, how to apply process mining projects. This is on conformance checking, so if you want to know more about conformance checking, this is the book. And applying in healthcare, and this book is also on modeling, which is very important. That's all from my side. Thank you very much. I don't know if we have time for questions, the organization. Yeah. Are there questions? Yeah. Yes.
Thank you. Hello. Yeah, thanks, first of all. So what I'm wondering, in earlier versions of these summary views or 360-degree views, there was always process enhancement as well.
Yeah.
So as part of these, like, I don't know, like 3 bigger branches of process mining with process discovery, conformance checking, and then process enhancement. Now in this view, I don't really see that anymore, and I'm wondering what happened to it, where its whereabouts.
It is there, it is there. So for instance, if you look at the conformance checking book, process enhancement is considered also as a discipline sitting next to it and kind of represented by it. So I would say it's in this constellation, it is there, it is important, and of course takes part of it. And I would say you can consider something in between. And performance analysis is perhaps something that also covers part of it. So I think it is represented, and it's more like a syntactic sugar. It's not, so all the fields, all the problems that are addressed are still important and are there. So
okay, thanks.
PQL.
Yeah, PQL, yeah.
PQL. So the idea, let me check, go back a bit. The idea, I'm not an expert, I have to say, but the idea is that you can, so Celonis is meant to be used by different users. One of the users could be someone that actually wants to drill down on the event data, but not really doing, let's say, search on the Excel file, nothing like this. But instead, being able to program queries on the event data. I don't know DAX. It's process oriented.
Yeah, I believe there's an open chapter that is free on web that you can search for the process querying language, and you have like the basic commands. Like if you want to check like the time between one activity and the other one, you can have the output. Okay, so it's a kind of querying language made especially for the process.
Yeah. Okay. Questions?
What are the most benefits of the process mining than the organization buying actually from the Celonis or something? What are the core benefits of process mining for the companies? What they are paying for in Celonis or the other tools?
Well, I can only report on some use cases that I have seen. For instance, they were reporting on Vodafone being able to save. You are asking for benefits. So in the web page, you can see many use cases. And for instance, I can explain and I can report on Celonis, Vodafone reporting on saving millions of euros on daily basis because they have huge data and improving a process continuously. Just one that was affecting many data was really improving a lot of, saving a lot of money. So this company sees that, and actually they are very well, this software, they are very well set to be configured so that they can gain all the value they have. So I think it's clear. What do you want? Okay. So maybe 10:45. So we maybe a couple of questions more, and we will have a break. It's not because I don't like to answer questions, because someone might need coffee and.
I think you said that for conformance checking, we should first, if we have a DFG, we should convert it to BPMN.
Yeah.
Then we do a conformance checking. So if we cannot convert it to BPMN, what should we do?
Well, there are techniques, Sanders, for doing conformance checking on DFGs. I think you. So they transform to a Petrinet, and then there should be some kind of trade-off between the quality of what you get. But actually, there would be a way always to maybe losing accuracy or to convert. There is always possible. At the end of the day, if you have a DFG, you can reply, get the traces, and get the process model. But you can do more interesting things instead. But you can always turn it into, you can always change to a Petrinet. But Sorry? As I said, it's something that you can do. It's something that you can do. You can, for instance, get rid of some traces that might not be easy to be represented in a Petri net, but at the end you can always do, because at the end it's a language. So you can select the traces that you want to represent and move them to another formalization. It can be done. With a loss of an accuracy, but it can be done. Yeah.
The aim of action-oriented process mining is to improve the underlying business process in general, or with respect to a performance measure during runtime or offline time. And what are the techniques that are used in the action-oriented process mining?
Can you repeat the last question?
Techniques that are used for action-oriented.
So to be honest, I don't know what do they have inside, okay? So this is a very, very new branch of research. I don't know how they connect the insight from, so maybe this is something that you should ask to some of the Celonis guys, because this is kind of very new. So there are very few tools, academic, commercial tools that do this connection to execution. And the way they do, honestly, I'm not very certain of how to do it. But it is, I mean, the aim is simply to be able to do a non-trivial step to go from simply modeling and visualization to something that has a counterpart in the data you are generating. So because you are executing again. So you move from something, you executed something, you store data, you discover process model, do alignment, performance, and then at the end, you get a new model, which is not a model anymore, it's an execution engine that executes something that you have told. The way you do, I cannot tell, sorry. Any other questions? Yeah.
Thank you very much. Yes, I had a question about, I'm missing a little bit on data validation. As it stated, process mining visualizes reality, but does that include also data validation? Because data reality is something different than process reality.
Absolutely, absolutely, absolutely. I think it's a very good question. Actually, there is a session by Jochen who would explain how to gather data, how to validate, how to actually improve, how to get rid of things that are noisy, how to assess whether something is noisy or not. And this is a huge, important step. So it is kind of measure that 40% of a process mining project is only on data gathering and validation. So it is very important, and we need to break because Bodewan is telling me, but there is a last question there. Last question.
Just quickly, because there were questions about the application of Celonis. I'm Axel, I'm here all week. I'm not from Celonis, I'm a user, so we applied in our company. I'm from Olympus, so if you have questions, just approach me during the week.
Thanks, Axel. So let's go for the break. Thanks again, and see you around this week.